Welcome to Algebra 1. The learning goal for this episode is to learn how to solve a system of linear equations by elimination. We previously learned how to solve a system of equations both by graphing and by substitution. With graphing, it's sometimes hard to determine the exact point where the lines intersect, and substitution works best when there's a coefficient of 1 in front of one of the variables. We'll learn a third method, elimination, for other situations. The elimination method involves 3 steps. We add or subtract the equations from each other in order to eliminate one variable. If necessary, we multiply one of the equations by a constant first to help you get terms that will add or subtract out. The second step is to solve the resulting equation for the remaining variable. Then finally, we substitute that value into either one of our original equations and solve for the remaining variable. That may sound confusing, but it makes sense once you see an example. So let's look at some examples. We want to solve this system of equations by elimination. In this case, I notice that the first equation has a positive 5y and the second equation has a negative 5y. I know that if I add those together, the y's will subtract out, leaving me only x's. So I add the two equations together. I can do that because both sides of the equation are equal, and if I add equal things to equal things, the result will be equal as well. When I add them, the y's subtract out and I'm left with 10x equals 80. I know how to solve this. I divide by 10 and that gives me x equals 8. Now I can substitute 8 in for x in either of the original equations. I chose the first one just because the numbers looked a little friendlier, but I could have chosen either equation. Now I solve for y and get y equals 4. That means my solution is the ordered pair 8, 4. Since there are several places we could have made mistakes, it's always a good idea to check our solution. We do that by filling 8 in for x and 4 in for y in the other original equation. In this case, 6x minus 5y equals 28. When we do that, it does indeed work, so we know our solution is correct. Let's try another example. This time I notice I have a positive 5y in both equations. I know if I subtract this time, instead of add, the y's will subtract out. So this time I'm going to subtract the second equation from the first. We have to be very careful when we subtract that we subtract on both sides, which means we need to distribute that subtraction across all the terms. That leaves me with 4x on the left side and 6x minus 18 on the right. I know how to solve this. When I solve it, I get x equals 9. Now I substitute 9 in for x in either of my original equations. This time I chose the second equation since it was already solved for y, since that'll be quicker to figure out the value of y. In this case, y equals negative 2. So our solution is the point 9, negative 2. We check it by substituting it into the other equation and seeing if it works. It does, so we know our solution is correct. Here's another example. This time I notice that I can't add or subtract and have any of my variables add or subtract out. But if I multiply my first equation by 2, then I'll be able to add the equations and the y's will cancel out. Again, as long as I multiply both sides of my equation by 2, it will still be equal. Now I add the equations to get x equals negative 28. I substitute that into either original equation, then solve for y. And I get y equals negative 21. So my solution is negative 28, negative 21. I check it in the other equation, and it works, so my solution is correct. Let's try one last example. This time I'm going to have to work harder to get my variables to add or subtract out. I'm going to multiply both equations by a constant in order to get terms I can cancel out. I notice that my x's are easier to work with, so I'm going to think about what I could multiply by to get my x's to add or subtract out. If I multiply my first equation by 3 and my second equation by negative 2, then the coefficients of x will be 6 and negative 6, respectively. Now when I add the equations, I only have y left, and I can solve and get y equal to 6. I substitute that into either of my original equations and solve for x. So my solution is negative 1, 6. Again, I should check it by substituting into the original equation. It does indeed work, so it is our solution. Now for our guided practice section, we're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you with the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself, then I'll show you. So, for this problem, our first question is, what are we trying to do here? What we're trying to do is solve the system of equations by elimination. How do we do that? Since we have a positive 2y and a negative 2y, we should add these equations together. Now what? Now we solve for x. What's next? Next, we substitute 2 in for x in one of our original equations. I picked the top equation, but you could use either one. So what do we do next? We write our solution as an ordered pair. Are we finished? We could be, but it's best to check our solution in the other original equation. Does it work? Yes, it does. Our solution is correct. Let's try another one. What are we trying to do here? Again, we're trying to solve this system by elimination. What do we do first? This time we're going to have to multiply both equations by a constant. What should those constants be? Depends on whether you try to eliminate x or y. In this case, it looks easier to eliminate y, so we'll multiply the first equation by 2 and the second equation by 3. Note that you could decide to eliminate x by multiplying the first equation by 5 and the second by -4. What's the next step? We solve for x. Now what? Now we substitute our value for x into one of our original equations, then solve for y. What's our next step? We write our solution as an ordered pair. Then what? Then we should check our solution in the other equation. Does it work? It does, so our solution is correct. Let's try one more. Again, we're solving by elimination. What's our first step? Well, I chose to multiply the first equation by 3 and the second by 2 to get rid of my x's. But notice that in this case, that also got rid of my y's. Now what? Since 0 is never equal to -4, that means these lines never intersect, so they must be parallel. Therefore, our answer is no solution. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here's the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem, and work it out in your notebook. Then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve a system of linear equations by elimination. We did that by adding or subtracting the two equations to eliminate a variable, sometimes after multiplying by a constant. We then solved for the remaining variable, substituted that value back into one of the original equations, and solved for the other variable. We then checked our answer in the other original equation to make sure it worked.